Good morning, students. Today's lecture focuses on three critical unit operations in dairy plant processing: chilling, clarification, and storage of milk. These operations occur immediately after reception and determine the microbiological safety, physical cleanliness, and stability of milk before further processing. We will examine each stage systematically. This slide introduces the milk chilling process overview. The flow sequence shown is reception, cooling, holding. Milk arrives at ambient temperature. It must undergo rapid cooling with a target temperature of 4 degrees Celsius. After cooling, milk enters holding tanks where temperature must be maintained at 4 degrees Celsius. The key concept here is the beginning of the cold chain. Rapid cooling prevents the initial microbial load from multiplying before processing. The need for rapid cooling is clearly illustrated by the bacterial growth curve shown on this slide. The graph compares bacterial growth with increasing temperature. The safe zone is below 4 degrees Celsius, where bacterial metabolism slows significantly. The danger zone lies between 10 degrees Celsius and 40 degrees Celsius, where bacteria can double every 20 minutes. Delayed cooling leads to irreversible spoilage. Thus, 4 degrees Celsius is considered the golden rule of dairy preservation. Several chilling methods are used in dairy plants. First, plate heat exchanger. It allows instant cooling using counter-current flow of chilled water or glycol. Highly efficient for continuous processing. Second, bulk milk cooler. Uses direct expansion refrigeration. Common in collection centers. Third, ice bank tank. Stores thermal energy. Ice is formed during off-peak hours and used for cooling during peak load. Fourth, glycol chiller loop. Uses glycol solution as secondary coolant, allowing temperatures below freezing without pipe damage. Selection depends on plant capacity and design. Let us now move to clarification. The objective of clarification is to improve the aesthetic and physical quality of milk by removing visible dirt, sediment, and somatic cells. The principle involved is centrifugal force. In a disc stack clarifier, heavier particles are thrown outwards towards the sludge space while lighter milk flows inward and upward. The equipment used is a disc stack centrifuge, which operates continuously with auto desludging. This slide explains the principle of clarifier operation. The operational sequence includes central feed. Milk enters through the central feed tube. Disc separation. Milk flows through conical discs at very high speed, often between 6000 to 9000 rpm. Sludge removal. Heavier particles move to the periphery and collect in sludge space. Clean output. Clarified milk moves towards the center and exits through the light phase outlet. The separation is purely based on density difference. What exactly gets removed during clarification? First, visible dirt and dust, such as straw, hair, and soil particles. Second, somatic cells. Leukocytes and epithelial cells settle in the sludge layer. Third, bacterial clumps. Although clarification is not sterilization, it removes larger bacterial aggregates attached to heavy particles. Thus, clarification improves physical purity, not sterility. After clarification, milk enters storage. The process flow is clarified milk, storage tank, dispatch. Storage tanks maintain temperature between 2 degrees and 4 degrees Celsius. The critical control point is maintaining steady 2 to 4 degrees Celsius to prevent microbial resurgence after clarification. Proper holding ensures quality retention. Different types of storage tanks are used in dairy plants. Vertical silo tanks. Large capacity, double-walled with insulation, usually installed outdoors. Horizontal tanks. Indoor stainless steel tanks with mechanical agitation. Bulk milk coolers. used mainly in collection centers with direct expansion cooling. Buffer or day tanks, smaller tanks used to balance process flow. Tank selection depends on plant layout and volume. General practices in milk storage include CIP hygiene. Tanks must be rigorously cleaned and sanitized between batches. Gentle agitation. Low-speed mixing prevents cream separation without damaging fat globules. Strict temperature control. Maintaining 2 to 4 degrees Celsius inhibits psychotrophic bacteria. FIFO principle. First in, first out ensures older milk is processed first. These standards maintain biological stability. This slide highlights the quality link between chilling and clarification. Chilling controls temperature, maintaining 4 degrees Celsius to arrest microbial growth. Clarification removes physical impurities and somatic cells. Together, they produce market-quality milk with extended shelf life, superior flavor, and enhanced safety. Process integration determines final quality. The process summary illustrates the complete workflow: reception, chilling, clarification, storage. Reception ensures raw material quality. Chilling reduces temperature to 4 degrees Celsius. Clarification removes dirt. Storage maintains cold conditions until further processing. Finally, quality is verified before milk enters pasteurization. To conclude, chilling controls microbial growth, clarification improves physical cleanliness, storage preserves stability. Together, these three operations form the backbone of dairy plant pre-processing. Without proper control at this stage, downstream processes cannot compensate. Thank you.